Okay, welcome back. We're going to continue with our sine law practice. And this time we have a couple of word problems here where we're going to focus on how to uh, first create a diagram from the words, where to put the numbers in the diagram, and then how to determine what you need to find. Okay, because that's usually the toughest part when it comes to word problems in trig is getting the diagram, make sure you put the numbers in the right spot, and then problem solving in order to figure out what is it that they're asking for. After that, then it's just applying the formula and substituting in the numbers, which is very simple, right, for the most part. So in this first example, in 8.2, we have Aaron, Bob, and Chris are standing in a triangle. So 3 points. Okay, doesn't matter where you put them or who's first or anything like that. Bob is 54 meters away from Chris, and the angle between Bob's lines to cite Aaron and Chris is 50 degrees. Okay, so it's talking about Aaron, Bob, and Chris. Aaron, Bob, Chris, right? That makes sense, or hopefully it makes sense to you as far as why we used ABC, right? So it would have made sense if it was Sharon, Julian, and Margaret, we would have used S, J, and M, right? So we're trying to use initials or letters on the vertices that coincide with the words in the situation. Bob is 54 meters away from Chris. So here was Bob, B. Here's C for Chris. They are 54.0 meters away from each other. And the angle between Bob looking at Aaron and looking at Chris is 50 degrees. The angle between Aaron, who's A, looking at Bob and looking at Chris is 34 degrees. So let's put a 34 in there. How far is Aaron from Chris? Okay, that seems to be what the diagram is telling us. So you notice how I stopped. I didn't do too much all at once because then I would have forgotten the previous numbers. And I went back and I reread it and I reread it. And then I stopped and I put the numbers where it told me. And then I went back. So do whatever works best for you. If you're good at reading the whole thing and remembering it, do that. For me, I like to do it basically one sentence at a time or one number at a time. All right, so we have little c over here, but that doesn't seem very important. We have little b down here, which I'm going to label. That's important because that's the unknown. And we have two angles and another side. So again, strategy now. We got the diagram, we've labeled it. Do I have 90 degrees in this triangle? No, I don't. So I can't use SOHCAHTOA, I can't use Pythag, I can't use anything like that. I can still use angle sum of a triangle though, the 180 rule. That still applies. So do I have a complete angle inside? So I know this angle, but I don't know this side. But I do know this angle, and I know that side. So because I have those two pieces of information, and they go together, little a with big A, because those two go together, that means this is sine law. This is a setup for sine law perfectly. And because what I'm looking for happens to have its angle already known, I don't have to use the 180 rule because angle C isn't important here. It's not helpful. But angle B is going to be useful, angle A and little a. So I'm going to set up sine law so that I'm going to put the sides on top. And again, you don't have to, but again, it just makes your solving easier for yourself if you do this preliminary processing. So whether I put little a first or little b first, again, it doesn't matter. So I could go little a on top of sine capital A equals little b on top of sine capital B. Or I could put this side on that one and that one on that one. The order of the fractions does not matter. Then I'm going to fill in. You can leave off the 0.0. I'm not going to write meters. I'm not going to put units. Over sine 34. And again, you can't leave off the sine. The sine's important. It's not 34. It's 34 degrees. What are we taking 34 degrees of? The sine of that. So it's important that you don't forget that it's called sine law. So it has signs in it. Sine capital B is 50. So again, what I'm looking for happens to be sitting on top because I designed it that way, which means all I need to do is bring up the sine 50 to the other side. 54, I dropped the 0.0. I'm not interested in continually writing that down. Times sine 50, still with sine 34 in the bottom, equals little b sitting by himself. Calculator, degrees mode, check. Sine 50, I do the hard part first, then I go times 54 equals divided by sine 34 equals 73. Did it tell us? No, it didn't say how many decimal places, so one decimal place. So that 7 is going to cause that 9 to round up to a 10. So that's going to become a 0, and the 1's going to carry to the next level, which turns a 3 into a 4. So 74.0. So 74.0 equals B. And because it came to us in words, we respond back in words. So therefore, Aaron and Chris are 74.0 meters apart. So if you did it rounded here, you're going to round it down here in your final answer. All right, second one. A chandelier is suspended from a ceiling by 2 chains. So you're going to draw a ceiling. So we have a chandelier, so it's dangling, right? Now it has 2 chains holding it. So they're attached at 2 different points to the ceiling. So point hanging from a ceiling, that's what suspended means, by 2 chains. One chain is 46 centimeters long and makes an angle of 60 degrees with the ceiling. So it doesn't matter if I pick this one or this one. I'm going to call this one the 46.0 centimeter one. Oops, centimeters. That's a cm. Centimeters long, and it makes an angle of 60 degrees with the ceiling. The other chain, so the one that I didn't write the 46 on, is 64.0 centimeters long. What angle does the longer chain? So obviously 64 is longer, so this is obviously not to scale. This one should be longer, so it probably should go out more. If I was drawing, right? So the angle that's opposite the 46. But we have the angle in the side, in this case little p and capital P. So because again I know both those numbers, this is sine law. I have angle and side set up. So because of that, I'm going to set up sine law. And I'm going to set it up with the angles on top. So we're going to go sine capital P over little p equals sine q over little q. So go ahead and you're going to fill in your numbers. And then you're going to bring that up and multiply. All right, you're going to bring that up and multiply on the other side. And like I had shown you before, you're going to bring the sine to the other side just to get it all done at the same time so it doesn't take you another line to isolate for theta. And then when you enter it into your calculator, I do this part first, then that part, then that part, and then I don't bother writing this number down because I can't be bothered. And then I just inverse out the sine, and look at that. Nice clean angle. And that's not rounding, so I know this is pretty accurate. And because it came to me in words, I'm responding back in words. Therefore, the long chain makes 60 degrees with the ceiling. And I just read the last sentence usually and take those same words and put them into my therefore statement, and my units are right there with degrees. Right, so I hope that clarifies what we do and how we go about making